This is example 9-2, example 3. And so this type of example would be one that would be looking at if we were trying to figure out things about a roof. And so a museum, just like a bank, has a vault because they have very expensive, priceless pieces of art. And so this is a vault that is encompassing a smaller space, which you can see, right here, the smaller space. And they keep all of their priceless items in this vault. And it says that the vault is made out of steel, a steel wall around it. And the area of the vault, they tell us, it's 1664 feet squared. And tell me again, how do I find area?
And the shape here is a rectangle, so how do you find the area of a rectangle?
Has something to do with length.
Length times width.
Yes, Miss Bailey. Length times width. And they tell us that 1664 is the area of the vault and the outside steel wall. So it's the entire thing is the area of 1664. They give us the dimensions of the inside of the vault. So it's 20 feet by 40 feet. So the inside is equal to a width of 20 feet and a length of 40 feet. But that does not include the steel wall on the outside. The steel wall on the outside, it tells us right here, the width of one piece of it is X. So that means that this is X, this is X, this is X, and this is X. So the width of the entire piece all the way around. So if we wanted to find the length and putting on our quadratics hat of what we've been doing, if we wanted to find the length, then the length is going to be the 40 feet of the inside plus the 2 extra pieces of the wall. So how could we write that? We would say 40 plus this piece, X, plus this piece, which we said is X. Who can simplify that for me?
What'd you say again?
Who can simplify that for me by like combining like terms? What are
just squared and 40?
So would it be squared?
No, it wouldn't. It'd be 2x.
Yes. So our length, written the way that we're used to writing quadratics, is going to be 2x plus 40. And we always put our variables first.
Mm-hmm.
Andrew, what's the width? I'll give you a hint. It's 20 to start with. Plus what?
40.
20 plus what, Andrew?
20.
So we've got 20 plus this piece and this piece.
What are those pieces called?
What pieces?
The little extra piece that's around the entire vault. We named it something because we don't know the exact measurement.
I'm not sure.
Okay. So this piece, we know the width of this is X. So we have to add that to our 20, which is only the measurement of the inside. And then this piece right here, which McMunn is showing you, is X. So therefore we have to add another X because we have a piece here and a piece there. So we have to put all of our pieces together. So now that we have a width of 20 plus X, can we simplify that?
Yeah.
What is it, Andrew?
I don't know.
How can we simplify X plus X?
Minus it.
What do you think, Cayman?
On what?
How do we simplify X plus X?
I don't know.
What is X plus X?
It's 2x.
Yeah.
Explain how you got that, Bailey.
Because like x to me represents 1, so 1 plus 1's 2.
Very good, very good.
Plus 20. So now that we found the actual dimensions using the X, because we don't know what the X stands for yet, that's what we're going to solve for. What is the width of the outer steel wall? So we're going to find out what X is. We're going to use our area formula because we have the length now and we have the width. So in using our area formula, it's simply length times width, so 2x plus 40 times 2x plus 20 equals, and what was our total area that they gave us in the problem?
What did it tell us up here? That the entire area that up here, Miss Harrison?
Uh-huh.
It told us the entire area was this right here.
So the entire thing, the length times the width, which is what we've put together so far, is equal to 1664 feet squared. Do you see that?
Yes, ma'am.
All right, perfect. So now we're going to FOIL it out, or we could use the box method. Which one would you prefer?
Box.
Box, okay. So we have 2x plus 40, 2x plus 20, 2x times 2x,
Amen. Andrew, Bailey, anybody there? 2x times 2x?
what is 2 times 2?
4.
Good.
What is x times x?
X
X
squared.
squared.
Yeah. Now 2x times 40. 2 times 40.
80.
Mm-hmm. And there's nothing to multiply the x by, so you just bring it over. 2 times 20?
20x or 40x.
Yeah, 40x.
Very good.
And then this is when you might need your handy dandy calculator. What is 40 times 20?
800.
Good job. So now we can bring it out. We've got 4x squared. Combine these two, what do you get?
120
120 what?
x
Very good.
And then we have plus 800 is equal to 1664. Last week, what was the first step that we talked about to be able to solve quadratics? We had to have what on the right side?
A 0.
Yeah, we had to have a 0 on the right side. So how can we get rid of this positive 1664?
Subtract it by 800.
I agree with subtract. What's another option?
L.
Say that again, Bailey.
Subtract it by itself.
Yes. And so whatever we do to one side, we have to.
To the other.
So now we have 4x plus 120x. And what is 800 minus 1664?
negative 864.
Excellent, Cayman. All right. Those are some big numbers, huh? Do y'all agree?
Yes, ma'am.
Yes.
So we have a preceding number on our A, because remember we have ax squared plus bx plus c equals 0. That's the standard form of the quadratic. And what is our A?
What is our A, guys? What number represents the A in this form?
Miss McMunn circled it for you.
Looks like
4.
it's for Cayman. Thank you, Cayman. Yes, it is 4.
So it's 4, and I'm looking for a way to simplify because these are really big numbers. And so the first thing I'm thinking about is if this is 4, can I divide these two by 4? They have to be even numbers. So check it with your calculator. See if we can.
So when we put them in our calculators, we want to get whole numbers out to make sure that 4 is evenly divisible by it. Or that it's
Yeah, I said even numbers. That wasn't right, was it? Because it could be odd.
Can you get whole numbers by 4 with 120 or 864?
Try it.
A shortcut for the 120 divided by 4 is to just look at the 12 divided by 4. What's 12 divided by 4?
3.
Uh-huh. And then you can bring along the 0. So that one would end up being 30x. I don't really have a shortcut for the last one, but if you have a calculator, it'll figure it out real quick for you.
What do you think?
That's 864 divided by 4.
216.
Oh, excellent. Positive or negative?
Negative.
And then we need to divide 4x squared by 4. And so what are we left with?
When you divide that first term by the 4.
1
1.
Yep, so we're left with 1 what?
squared or 1x squared.
Yeah, equals 0. And so now we can go to our puzzle, our x puzzle with the greatest common factor. So what we're looking for, and I have one of these printed out.
Hey, remember to put the 4 on the outside of your equation. You can't lose it, so just make sure that you keep that 4 out front of that equation. You see what I did? Whenever you factor that out or divide it out, you can't just let it disappear. It has to stay in the front there, okay?
So now if we look at we're looking for two numbers that when multiplied together, you have 216. And when added together, what do we have? Positive 30? So 216, and 216 is positive or negative?
Negative.
So if I write it up here, Ms. McMunn's helping me out and reminding me I can write it over here. All right, so it's negative. The way that I think about when I'm solving this X puzzle, if the number is negative and this number is positive, then the bigger number is going to have to be positive, and I'll show you what I'm talking about. So I always start with 1. 1 times what gives me 216?
216.
Yeah. So because it's a negative, we know that we're going to have a negative number and a positive number. But since this number is positive, the bigger one would be positive. So this would be a -1, a positive 216. If we add those together, what do we get?
So think about like you owe somebody $1 and then you just got a check from your boss. You just made $216, but you still had to pay that $1 you owed. So how much money would you have left? How much money do you start with?
216.
Good. You paid $1 out. So what do you? You're right. So is that what we need here?
So 216 minus 1 is 215. So that's not it. What about 2?
What is 216?
2 times what is 216?
432.
Okay, that's what 2 times 216 is. But what do you need to multiply times 2 to get to 216? So you can think backwards and use division. So take 216 in your calculator and then divide it by 2.
8.
108.
Mm-hmm.
So 108 minus 2.
Will that get us our 30 that we need?
No.
Nope. So what about 3? Does 3 go into 216? I don't know if it does or not.
It does.
What is it?
72.
So 72 minus 3.
Does that give us the 30 that we need?
Mm-mm.
All right, so what about 4?
54.
54 minus 4 is 50. So that's not right. 5 won't go because this is not a 5. What about a 6?
It's 36. It will work.
Down works.
Mm-hmm.
36 minus 6 is 30. So that's our factors.
Very good.
So now we can go back to this page and factor it out. So we have x minus 6, x plus 36 is equal to 0. So now we just break it apart like we did before. When we break it apart, x minus 6 is equal to 0, and x plus 36, oops, didn't need to do that, is equal to 0. And then 4 does not equal 0, so we factored it out.
So it can disappear now because we know 4 doesn't equal 0.
Yep. So we have x minus 6 is equal to 0. How do we solve that? Solving for x.
Add 6 to itself and then to 0.
And so we get x equals what?
6.
Mm-hmm. Andrew, solve this one. X plus 36 equals 0. How do we solve that?
Say that again.
Solve this one. We've got x plus 36 is equal to 0. So how would we solve for x?
Well, X is 0.
Well, x plus 36 is 0. So how do we get the x by itself? What's attached to it right now?
Then it'd be negative 36.
There you go.
Excellent, because you subtracted 36 from both sides. So perfect. Now we need to go back to intuition. So we have an x equals 6 and an x equals a negative 36. We were asked in the original problem, going back up, remember we've got x equals 6, x equals a negative 36. What is the width of the outer steel wall? Can you have a negative width?
No.
No. So the only one that makes sense is this x equals 6. So a lot of times, and Miss Harrison's guilty of this, a lot of times when I get knee deep in a math problem, I'm so focused on what the correct solution is that I don't go back and check what was the original problem, what did it ask me, and does it make sense? And so like in this situation, if you answered x equals 6 and x equals negative 36, well, only half of your answer would be correct because you can't have a negative 36 length. That doesn't make sense at all. So, you know, think through what you're doing and make sure that you don't fall in the trap that I do. Sometimes I get so excited over doing the math. I know y'all would never do that. But I get so excited over doing the math that when I get a solution, I feel accomplished and I want to keep both of them. And you can't do that. You got to figure out which one actually answers the question. Are there any questions?
No, ma'am.
Mr. Brandon, how you doing?
Good.
All right. Let's look at another example, very similar. To the previous one. And so this one reminded me when I was looking at this example of when we talked about perimeter and how we were going to put a fence around the pool when we were doing units. In this one, we have a swimming pool and it's twice its width. So its length is twice its width. And there's a deck around the outside of the pool that has a universal width or a uniform width of 2 feet. So that's 2 feet, this is 2 feet, this is 2 feet, and this is 2 feet. And it says that the total area, which is the pool and the deck, is 96 feet squared. So it wants to know what is the dimensions of the pool. And we're going to use our area model again. Area is equal to length times width. What is our length? The pool piece is 2x. What do we need to add to it to include the deck?
What does it tell you the additional part is? It tells you in the problem, the uniform width all the way around is this number right here. What is that number?
2.
Mm-hmm. So that's what we have to add to it because that is this part right in here.
And so we have to add 2 for the left side and 2 for the right side. So 2 plus 2 is?
4.
And so then, what is the width? The width of the pool right here is x, but we've got to add the deck pieces. So how much do we add?
What was that uniform all the way around? What was that number?
So it's the exact same.
It's 2 on this side and then 2 more on this side.
2
So
plus,
what would you be adding to the whole thing?
4.
Very good.
Yeah. So now we're going to look at our area model. And we have length, 2x plus 4, and width, x plus 4. And what was our total area that it told us in the problem?
96.
Yeah, equals 96. So we're going to box it. And you've got 2x plus 4 and x plus 4. 2x times x.
2x squared.
Yep. X times 4.
4x.
2x times 4.
8x.
Mm-hmm. And then 4 times 4.
16.
Perfect. Now we're going to combine and bring it out. 2x squared plus 8x plus 4x. What's that?
12
12 what?
x
Mhm.
Plus 16. So we're going to go back over here. And we've got 2x squared plus 12x plus 16 is equal to 96. What do we need on that right side? It's got to be equal to what?
0.
Yes. So to get a 0 on that side, we've got to subtract the 96. So we have 2x squared plus 12x, and then what is a positive 16 minus 96?
negative 80.
Yeah.
Very good. Very good.
Now, once again, I'm seeing that we have a 2 here for our A, and 12 I know is divisible by 2, and 80 is an even number, so it's also divisible by 2. So what can I do? Can I
Divide by 2.
divide the entire thing by 2? Whatever you do to one side, you got to do to the other. That gets rid of this 2. You've got x squared. And then plus 12x divided by 2.
6
6.
x
80 divided by 2.
negative 40.
And then 0 divided by 2.
0.
So that gets rid of that negative 2. Now we go back to our puzzle. We want something that multiplies together to give us a negative 40 and adds together to give us a positive 6. A positive 6. So let's look at, oops, I keep moving, Miss McMunn, I'm sorry. So let's look at our greatest common factors. We have, for a negative 40, 1 and 40, right? Brandon, I thought I heard you. I'm sorry. So we have a negative 40. We know that we're going to have a positive and a what? Multiplied together to give us a negative.
So our product needs to be a negative 40. So we need to get a negative out of it. What two things can you multiply together to get a negative outcome?
So we're going to have, hang on, I'm trying to find it. There we go. We're going to have a positive and a what?
A negative.
And a negative. Exactly. So we're going to have a positive and a negative, and the 6 is a positive. So which one's going to be the positive number, the bigger one or the smaller one? Because when we add them together, we want a positive number. So which one's going to be positive, the bigger one or the smaller one? If the end result is positive, then the bigger one needs to be positive when we add them. Okay, so what is 40 minus 1?
It's 40. Or it's 39.
Yes. So that doesn't work. What about negative 2? -2, what do you multiply by -2 to get -40?
20.
Mm-hmm. And then, so 20 minus 2 is?
18.
Mm-hmm. So that doesn't work. 3 won't go into 40, but what about 4? -4 times what equals 40?
10.
10. 10 minus 4 is?
6.
That gives us exactly what we need. So we have x minus 4, x plus 10 is equal to 0. Break it apart. X plus 10 is equal to 0. X minus 4 is equal to 0. So x equals what on this side?
What is attached to the x? How do you undo it to get the x by itself?
Add 4 to both sides.
So what does x equal on that side?
4,
Very good.
What about on this side?
10. No, -10.
Excellent, Cayman. You subtracted 10 from both sides. What was our question to start with? Do you remember? What are the dimensions of the pool? So basically it's saying, what is the length and the width of the pool? Well, we know that it was x was the width, 2x is the length. So width equals x, length equals 2x. Can we have a -10?
As a length. So if we were to put that in there as the width, like, can you have a width of -10 feet? Is it possible to measure -10 feet?
What do you think, Andrew?
Is it possible to measure -10 feet?
No.
No.
No. So can we have that one as a solution?
No.
So the only possible solution is x equals what?
4.
Yep. So the
So-
width equal what?
4.
The length would equal what? It's 2x. So if you've got 2 of these x's, what would it end up being?
2x squared.
Okay, so you're saying to times it by an x. Okay, so we already know that x is 4, so you need to plug in that 4 where the x is. So what is 2 times 4?
8.
So there you go. The length is 8 feet, which is double what your width is. All right, are there any questions?
No, ma'am.
Just make sure you break down each little piece of information, right? So now we're going to look at one more example, and it's not a word problem. But I do want to look at this. This is example 4. It's on page 365. There is a try it that goes along with it. So you'll have the try-its for your assignment for this week. So we have, how can you use factoring to graph the function? So the very first thing you're going to do right here, first thing, factor. So we want to know what factors of 8, which is the -8, can we add together to get a -2? So let's look at the factors of -8. First of all, this number is negative. So when we add things together and we get a negative, does that tell us our bigger number or our smaller number is going to be negative? Which one do we want to win out? A positive or a negative? Come on, guys. Which one do you want to win out?
The negative.
The negative. So if the negative is going to win out, then the bigger number has to be negative. All right, so +1, -8, if we add those together, we get
-8.
Have $1 and then you owe somebody 8.
-7.
Very good.
yes.
So does that give us what we need over here? The -2?
Mm-mm.
So +2. What do you multiply by +2 to get a -8? +2 times what gets 8?
-4.
-4 plus 2?
Is 2.
Positive or negative?
Negative.
Yeah.
Is that what we needed over here?
Mm-hmm.
Yes. So we just found factors.
So now we can write it down. We've got x plus 2, x minus 4. And to solve it, we have to set it equal to 0 because that's our second step down here is to solve and break it apart. X plus 2 equals 0. X minus 4 equals 0. So now what is x plus 2 equals 0? How would we solve for x?
Okay, what's attached to the x? How do you undo it?
-2.
Subtract 2 but from both sides.
So x should equal.
-2.
What about this one?
It's gonna equal -4. Or no, it's gonna equal 4.
Are there any questions as to where Bailey got the +4? Andrew, are you still with us? Andrew.
I don't think he's there anymore.
I think he's muted.
Oh my goodness. Unmute yourself, Andrew.
Okay, we'll proceed. So we have x equals a -2 and x equals a +4. Don't lose that because let's go back to the question and it says, how can you use factoring to graph the function? What is another way that we can write f of x? What's another variable that we use for f of x?
So f of x is just the function of x. And you remember the input is the x. and the output is the f of x, or what is that other letter called output? There's an x and there's a what?
What's this axis? Y? Yes, no, maybe so?
Mm-hmm.
Okay, so we have f of x or y is equal to x squared minus 2x plus 8, and we found in our problem that x is equal to a negative 2 and x is equal to a positive 4 when what? When y is equal to 0. That's the whole reason why we set them equal to 0. So basically this is x plus 2 is equal to y. And if you were to graph this, this is what you would get in Desmos. What is this? Tell me that coordinate.
What would go in the parentheses for the coordinate here?
Your x is what?
These go by twos. So what would this one right here be?
-2.
Very good. And what would your y be? Does it go up or down any?
0.
Exactly. Very good job, Brandon.
What about this one?
4.
And then what's your y?
0.
Very good, very good.
So in answering the question, how can you use factoring to graph the function? Once you solve the function by factoring, just like we did, you know that's the points. That's exactly what we're solving for, is the points where the function crosses the x-axis. So your y is going to be 0. So you can put you a point on -2, 0, and you can put a point on 4, 0, and you know that when we graph quadratics, it's that U-shaped, it's the parabola. And so you might not have it exactly right, but you at least know that those 2 points are points on the parabola. So that's how you can graph using factoring to sketch out a graph of a parabola. It doesn't have to be exact. The most important thing is that it goes through these points and that you understand that when you're solving, those are actually the points on the graph you're solving for. Pretty neat?
Mm-hmm.
That wasn't convincing, Miss Bailey.
I'm sorry.
So we have -2, 0, and 4, 0. And that was our solution. Are there any questions, guys?